Hello everyone. Welcome back to our channel ML for Analytics. I am Jyoti Dikshit and in this video I will be talking about reducing data model size in Power BI report. So in this particular video we will be discussing the techniques or you can say hacks which we can use in order to optimize our Power BI report. So let's get started. So fine. Before talking about that, let's just talk about import model. So basically in Power BI we have many storage modes. One of them is import mode, second one is direct query mode, and the third one is dual mode. And in this particular case, we will be talking about import mode or basically the model which is formed by means of import storage mode. So data stored after compression. In case of Power BI import storage mode, the data which you fetch by means of the storage mode is usually stored in Vertipack engine after compression and optimization. So Power BI is capable of achieving around 10 times compression. So basically, if your original data was of 10 GB, then after compression it will be like 1 GB. So basically, additional 20% can be achieved when persisted to disk. Still, even after that, our focus should be on reducing model size by our side only, as in we can use some of the techniques in order to reduce our model size so that many of the problems will be solved. What are those problems? So one of them is a large model may not be supported by the capacity. So we have like Power BI Pro capacity, premium capacity, and all these things basically. So in case of shared capacity, we have this space limit of 1 GB, and in case of premium capacity, we have a workspace limit of like 13 GB. So if your report or if your model is basically very huge, or if its size is very large, then obviously this will be causing many problems for you when you will be hosting it on Power BI service. Then second one is obviously the smaller the model, the more reduction in the contention of resources. So basically, particularly memory, we are talking about here. So like if your model is smaller, then obviously it will consume less memory when it will be loading. So more models, they basically take they basically at the same time get loaded. So concurrent loading of many models or multiple models is achievable when your model is smaller in size. Then faster data refresh. So obviously if the data model size is less, then it will take less time in order to get refresh. And then lastly, we have like faster calculation evaluation. So many of the evaluation or calculation that we have done in Power Query Editor or by using DAX, obviously they will be taking less amount of time, and in that way, faster calculation evaluation will be there. So now comes the techniques. So the first technique is obviously to remove unnecessary columns. So suppose you have like uh, a table which is having like hundreds of columns, and you actually want to use 25 of them in your report, then it will be useless to import all of those 100 columns, right? Because your requirement gets satisfied by using those 25 columns only. So the rest of the 75 columns will be of no use for you, and if you are going to import them in your model, then they will be taking huge amount of space, those problems will be there when you host the data model or the report on Power BI service, right? So it's better to optimize your report a little, to be clear on your requirement, and to remove unnecessary columns that are not required. So this is basically called as vertical filtering, right? And if your requirements change, and if there is a requirement that you need some of like 10 additional columns, then you can always add them, right? You can actually either you can change your SQL query, you can modify your SQL query, or you can directly add uh, modify that step in Power Query Editor. So, like if I talk about Power Query Editor, as you can see on my screen, I have already loaded three tables in my Power Query Editor. One of them is fact sales, the other one is dim product, and the third one is dim geography. So if I go to like dim product, then I'm fine with this product key. I need this, but I don't need this product label. Sorry. Then I can select this, and the other column which I don't want is basically this class ID. Then I'll select control, as in I'll click on control, and then I'll click on this column also. And if there is like any other column which I don't want, like style ID or color ID, or I also don't want this size, and size unit, measure ID, weight, or if there are like any other column which I don't want, then I can multi-select them and then click on remove columns over here. And this actually removed all those columns. Suppose now my requirements change and I want that size column back in my report, then I can always go to advanced editor over here, and I can delete this size column from this step, removed column step. And after this, when I will be clicking on done, then if you go to right, your size column will be there. Sorry, just a sec. Yeah, so it's over here. So in this way, you can work with this in your Power Query editor. And if you have all those columns in your SQL query, then you can modify the SQL query. You can add those columns over there. So adding columns is much easier than deleting them, because obviously at some point of time you may end up using one of the unnecessary column, and then if you're going to like remove them afterwards, an idea struck your mind and you think that okay, this was not required and I should change that, then basically it will be difficult. It may break your whole report, right? Then the second technique you can use is remove unnecessary rows. So this is basically called as horizontal filtering. So why will you want that, and how you can basically use this particular technique? So suppose you only want to filter by entity. Like I have a global sales data, and I just want my users to see the data for just India. Then what am I going to do? I am going to actually choose the data for only India. So I can add a where condition in the SQL query, or I can go to again Power Query editor, and suppose I only want a silver color over here. Then what I can do is I can deselect other things and other other color names, and I can just select silver over here, and I can click on OK. So as you can see, only those products will be there over here which have a color equal to silver. And I can delete this step if I want at a later time, or I can modify this particular step. Like I also want black colored products, then I can select black over here, and I can click on OK. So as you can see, it's very easy to add data than to delete it afterwards. So it's better to actually design your report, an optimized report, and follow all these steps from the starting only, so that you don't end up in a state of difficulty, right? So uh, so sometimes even you want to set row level security. You want one person to just see a data of UK, then obviously, or you want your users to only see data of UK. Then in that particular case, you will have to apply row level security in Power BI. But if you are going to filter by entity only, then this particular thing, this particular requirement of adding row level security, it gets eliminated. Then comes filtering by time. So suppose you only want the senior management to see data after January 2020, as in you are not much concerned with the data before that, and you just want, your senior management has sent you a requirement that they want to see the revenue which was generated after January 2020. Then obviously it doesn't make sense to bring the data from like 2015 itself. It's going to add to the mystery, and it's going to make your report very large, and it will be like unoptimized report. So both of them can be achieved in Power Query Editor. So like if you go to Power Query Editor, and if you go to like fact sales over here, and you only want to see data of like uh, February or something like that, you can always go to your date column, and you can add date time filters over here. So it's like many filters are there: before, after, between. You want to see data from 21st January 2019 to 31st January 2019. You can use this between filter over here, and you can add those dates over here. So this will be achieved, right? So then the third technique is group by and summarize. So again, in this particular case, what we are going to do is, suppose we have like huge amount of data. I have daily trades data, and after 2010, and if I am clear with the requirement that my users are only going to see the average, you can say, closing price by month, by year, then in that case it doesn't actually make sense to load the daily data, because if I'm going to load that daily data in Power BI desktop, and then I'm going to use DAX, I'm going to create measures and applying all those DAX-based functions, then it's going to take very large amount of time in order to do calculations and evaluations. So it's better to be clear with the requirement, right? And to actually do grouping and summarization at Power, Power Query Editor itself. So, like if I go over here, or if I just want uh, to see, as in how many keys, how many columns are there in case of each of these continents, then what I can do is I can add group by over here. I can select group by over here. I can choose the continent name over here, and I can, yeah, a count is fine with me. I will just say it as count of key, count rows operation is fine, and I can then click on OK. And you can see that grouping and summarization is achieved, and then I'm going to click on close and apply, and this particular table is going to be loaded. So this is how it is going to work. So obviously you will lose some of the details, because obviously uh, that particular cardinality, as in your it was basically a daily data and now you are converting it to monthly data. So obviously you are going to lose some bits of details, but as I said, you will have to be clear with the requirements first. Then fourth technique is optimize column data types. So in case of RBI, highest optimization is achieved in case of numerical data. Why? Because in order to basically compress and save this numerical data in the Vertipack cache, value-based encoding is used, so it's just a one-step process. But in case of text or non-numeric data, hash encoding is used. So each text value, it is given unique numerical identifier. This numerical identifier is stored in the data structure, and then hash lookup is going to be applied during storage, during storing and querying. So basically, it's like 2 and 3 step process, and obviously, it's going to be slow and it's going to take a lot of time. So it is going to be a tedious process. Then storing key columns as numerical data, it makes more sense. So wherever possible, it's a wise thing to basically save that save data in numerical form. So like if I go over here and if I go to like any place, find that in this particular case I have all the keys in numerical form, so yeah, it's actually fine. But sometimes what happens is that as you can see over here, in case of style name, this product and then 010101, this is written. So obviously in Power BI, this is saved in text as text data type, which doesn't make sense. So what I can do probably is I can actually go over here and I'm going to apply this split column. And what I'm going to do is maybe by number of characters or something. So number of characters, it is going to be like product. So it's actually 7, and I click on it. Then yeah, so it gets splitted over here, and I can delete this particular column, remove this particular column if I want, and I can rename this column over here. So I can rename it to style name, and so as you can see now it has been converted to numeric type, right? Numeric data type. So this is how you are going to use data type optimization. So then the fifth technique is custom columns. So it's always better to use custom columns in Power Query Editor than using DAX-based calculation columns. So why? So basically your calculated columns, the calculated columns that you're going to create in DAX, they usually get evaluated after the whole model is loaded in Power BI Desktop, and this is loaded basically, in case of Power BI Desktop, a compressed and optimized model is loaded. So all of the columns that are coming from Power Query Editor, they usually get compressed and optimized during loading itself. And after this, these calculated columns are going to be evaluated. So as you can see, in case of them, limited compression is achieved and it is going to be less efficient. So it's always better to add these columns in as custom columns in Power Query Editor itself. You can go over here and you can go to add column, and as you can see you have custom column option over here. You can write the expression over here, language based expression, or you can, if you know that your column is conditional column, then you can go to conditional column and you can add a conditional column by following these steps. So it will be better, it will be even better if these columns, they are added at the source itself. Then sixth technique is to disable Power Query load. So sometimes what happens is that when you are basically creating a combined data model, then that combined data model is basically a combination of many queries in Power Query Editor. So what you can do is you can actually disable the load for those tables and queries which are used for data integration in other queries. So that they don't get added to your data model size. So if I don't want this dim query to be loaded in my Power BI desktop, in this pack engine itself, then what I'm going to do is I'm going to right click on this particular table, and I will click on this enable load option over here, as in I'm going to disable it. It's currently enabled because this tick sign is available over here. So I'm going to disable it. After disabling it, it is going to be coming in this italic format, right? So seventh technique is to disable auto date time. So So actually, the date columns that you have in Power BI, they usually, if your auto date time is enabled, then for those date columns, and and a hidden auto date column is going to be created in Power BI, right? So if your data was actually starting from like 1960 and it's ending to 2000, so the data duration, the date duration is 1st January 1970 to like 1st January 1999, then it's going to create a hidden auto date column which is having all these dates from 1st January 1960 to 31st December 1999. So you can imagine how much space it's going to take. So, if because in this case particularly, you are going to then have two date columns in your model. One is hidden and one is not hidden. So this is basically created so that you have all those functionality available: year, month, quarter, day. So all those hierarchies available. But if you don't want them, then you can always disable it. You can disable it by going to Power BI Desktop, by going to File over here, then going to Options and Settings, then going to Options over here. And as you can see at data load itself, under this time intelligence option, you can uncheck it. So this will be disabled, right? And after this, eighth technique is to switch to mixed mode. So in this particular case, basically, as you know that if one of the tables that you're having is having huge amount of rows, its model size is large, then you can switch it to direct query storage mode. And so particularly in case of star schema, or snowflake schema, what happens is that usually fact table contains transaction data, daily transaction data or something like that. So you can use direct query storage mode for these fact tables, and for dimension tables you can use dual or import storage mode. So in this particular case, you will be this 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 is how you are going to switch to mixed mode, or you are going to switch to composite model. So suppose if you have a table which is based on direct query storage mode, and you apply any grouped or summarized expression, you are if you group that particular table, or you summarize that particular table, then that table, that summarized table, is going to be loaded in import mode. So this particular thing should be kept in mind. So composite model is another name of mixed mode. So if you want to learn more about composite model, you can take a look, you can watch one of the videos created by me on composite model. I'll provide the link of that video in the description box below. So, guys, with this, I conclude this video tutorial. I hope you find that informative, this video tutorial informative, and you actually follow all these optimization techniques in your day-to-day data modeling in Power BI. So, if you like this video, then please hit on like button. You can give your feedback to us, or you can reach out to us by means of comments. Share this video if you like it, and yeah, subscribe to our channel for to keep watching more such videos. So we will be covering, like we are already covering Azure, Power BI, DAX, and in the coming videos, even we will be covering statistics and all these things basically. So stay tuned. Thank you.